Imagine you are standing on Mars, dust swirling around your boots, the sky a pale orange, and you can't help but think, what if we're not the first ones here? Maybe Mars once had its own civilization, long before humans learned to walk upright or complain about Mondays. The thought is both thrilling and unsettling, like realizing your new apartment might have had tenants who left without telling anyone why. Mars has always been that one planet that looks suspiciously like it's hiding something. It is close enough to tease us, far enough to keep secrets. When you look at its rust-red landscape through photos sent by rovers, you can almost imagine ruins. Shapes that could be walls, domes, or maybe just rocks that enjoy tricking Earthlings. For decades, Mars has been the stage for humanity's cosmic curiosity. Our interplanetary what-if-in playground. Good evening, curious minds. I truly hope you will enjoy today's video. Before we begin, leave a comment and tell me where and when you're tuning in, and if you find yourself learning something new as you drift towards sleep. Consider subscribing, but only if you enjoy these calm journeys through the universe. Now, let's begin. But what if that curiosity is more justified than we think? What if, long before we sent our first robot to roll across its dusty plains, Mars already hosted a civilization? Maybe they were as intelligent as us, or maybe smarter, having skipped the whole inventing traffic jams phase of evolution. The idea sounds like science fiction, but so did landing humans on the moon, and we've done that, twice. The universe has a way of turning fiction into homework. Scientists have long known that Mars isn't just another barren rock. It's a planet that once had conditions remarkably similar to early Earth. It had a thick atmosphere, liquid water, and warmth. Three things every biologist looks for before getting excited enough to start writing grant proposals. Billions of years ago, Mars might have looked like the kind of place you'd move to if you wanted to escape Earth's constant meteor impacts. Now, picture that ancient Mars. Maybe it had shallow seas reflecting a salmon-colored sky. Maybe rivers carved canyons while storms rolled through a humid atmosphere. It's easy to imagine that somewhere along those ancient shorelines, life began to stir, cells forming, dividing, evolving. And if evolution had enough time and the right conditions, who's to say it couldn't have gone further? Maybe that early life built things. Maybe it learned to think, to wonder, to look up at the same stars we do. If there ever was a Martian civilization, their existence would have predated ours by billions of years. They could have risen and fallen before the first dinosaurs on Earth even showed up to audition for extinction. They might have built monuments, cities, maybe even technology we can't begin to comprehend. Then disappeared so completely that all we see now are whispers in the dust. The idea isn't entirely crazy when you think about how fragile civilizations are. If ours collapsed tomorrow, how long would our traces last? A few thousand years, maybe? Then the wind, the rain, and time itself would erase almost everything. On Mars, where erosion is slower and no rain falls, their remnants could still exist, just buried under meters of red dust, waiting for a curious rover to trip over it. The allure of Mars isn't just in its mystery, it's in its familiarity. It's Earth's smaller, colder sibling that never quite made it. Some scientists even call it a failed Earth, a planet that started the same way but lost the race for habitability. That's what makes the idea of an ancient Martian civilization so haunting. What if Mars didn't fail? What if it succeeded, but only for a while? When people imagine aliens, they often think of creatures from faraway galaxies, slimy, telepathic beings with questionable fashion sense. But the most realistic aliens might have lived right next door, just across the solar fence. Maybe they weren't little green men. Maybe they were something stranger. Organisms that evolved entirely differently under Martian gravity and atmosphere. Perhaps they were silicon-based instead of carbon-based, their biology sculpted by iron-rich soil and thin air. Or maybe, like us, they looked up at the stars and wondered if anyone else was out there. Ironically, that anyone might have been us, but a few billion years too late. The human imagination can't resist filling in Mars's empty landscapes with stories. It's how we cope with the vastness of space, by giving it personality, by pretending it remembers. Every dune and crater becomes part of a forgotten narrative. The universe doesn't leave diaries, so we invent them. Yet sometimes, imagination leads science. We dreamed of life on Mars long before we had evidence that it once had water. And, as it turns out, those dreams weren't completely misplaced. If we one day find proof, a fossil, a structure, or a microbe's last selfie frozen in ice, it wouldn't just rewrite history. It would remind us that life isn't an Earth-exclusive club. The discovery of a past civilization, even one that lasted a blink of cosmic time, would mean intelligence can arise more than once in the same solar system. And that's both exciting and humbling. It would mean the universe is not a lonely stage, but a crowded theater where civilizations appear, perform, and vanish, leaving only dust and questions behind. So, as you stand there in your imaginary Martian boots, staring at the horizon, the silence feels heavier. The wind sounds like whispers from a world that might have had its own cities, its own dreams, maybe even its own version of science communicators wondering about someone like you. The red planet suddenly feels less like an alien world, and more like a ghost of what could have been. A cosmic secret that's been hiding in plain sight. Billions of years ago, Mars wasn't the dry, rusty desert it is today. It had rivers, lakes, and possibly even oceans. Imagine the planet wearing a blue outfit instead of red. It might have been the solar system's before picture in a cosmic skincare ad. Back then, Mars wasn't the dusty neighbor we know. It was a planet with promise, the kind you'd swipe right on if the solar system had a dating app for habitable worlds. Today, Mars looks like someone left it in the oven too long. Its surface is cracked, arid, and sprinkled with iron oxide, the fancy scientific term for rust. But that rust tells a story. It's evidence of a planet that once knew moisture intimately, that danced with water across its surface before everything evaporated into thin air. Literally. Long before humans came along to name it after the god of war, Mars might have been more like the god of calm afternoons and partly cloudy skies. Let's rewind to roughly 4 billion years ago, during what scientists call the Noachian period. Back then, the planet wore a thick atmosphere, dense enough to trap heat and allow water to flow freely. Mars' landscape was sculpted by rainfall and runoff, carving valleys that still trace the planet's ancient waterways. If you look closely at satellite images today, those valleys still linger, like the wrinkles on an old face that's forgotten how to smile, but remembers that it once did. Picture this: great rivers winding through Martian plains, feeding into sprawling lakes. Imagine sunlight glinting off waves that rippled across crimson shores. There might have been clouds, rain, and even storms rolling over a watery horizon. In some regions, conditions were likely mild enough to make it a comfortable, habitable place, at least by ancient microbial standards. We know this not from guesswork, but from evidence scattered across the surface. The rovers, those little robotic archaeologists with more patience than any human, have found sedimentary rocks that could only form in liquid water. They've rolled over ancient lake beds, spotted mineral veins where water once seeped through rock, and even discovered clays that hold on to chemical memories of wet environments. Each of these clues is a postcard from a time when Mars was more Earth-like than alien. One of the most fascinating discoveries came from Gale Crater, where the Curiosity rover found layers of rock that looked suspiciously like those you'd find at the bottom of an ancient lake. If Curiosity had a face, you could almost imagine it squinting up at the Martian sky and saying, "So, where did it all go wrong?" Because at some point, this planet's paradise phase ended. But before that downfall, Mars might have been bursting with hydrological drama. There were deltas, triangular patterns formed where rivers met standing water, suggesting long-term, stable bodies of water. There were basins large enough to rival Earth's oceans, possibly covering vast northern regions. If that's true, Mars once had tides, waves, and currents. Maybe even Martian surfers, though that's definitely wishful thinking on humanity's part. Water wasn't just sitting there for show, it was working its chemical magic. Flowing water shapes landscapes, dissolves minerals, and helps create environments where chemistry gets complex. On Earth, that complexity gave rise to life. On Mars, it might have been stirring the same cosmic soup, waiting for the right conditions to cook up something alive. But while early Mars had the recipe, it didn't keep the kitchen open for long. The atmosphere began thinning, and as pressure dropped, the surface water began to vanish. But for a while, the planet was lively in its own quiet way. Imagine entire regions where rivers wove through volcanic plains, steam rising from geothermal vents, and maybe, just maybe, microbial colonies clinging to the edges of those warm pools. Mars' blue era wasn't a brief flash in cosmic time. It lasted hundreds of millions of years. Long enough for lakes to fill and drain. Long enough for rivers to cut deep channels. Long enough for weather to sculpt a planet that still bears the marks today. The Martian poles likely had ice caps back then, too, feeding seasonal meltwater that carved patterns across the terrain. These weren't random scratches. They were signatures of a living climate, one that breathed and changed. One particularly intriguing idea is that Mars had cycles, wet and dry periods that repeated over time, driven by volcanic eruptions and climate swings. Volcanic activity could have belched out gases that temporarily warmed the planet, melting ice and releasing floods that reshaped the surface. Then, when things cooled again, the water froze, the atmosphere thinned, and Mars went back into hibernation. This stop-and-start pattern might explain the mix of ancient riverbeds and frozen plains we see today. It's as if Mars couldn't decide whether it wanted to be a water world or a desert, and kept flipping the cosmic thermostat back and forth. When you think about it, this early version of Mars wasn't so different from Earth's own adolescence. Our planet also had violent volcanoes, heavy rains, and constantly shifting climates. The only real difference is that Earth managed to hold on to its atmosphere, while Mars slowly lost its grip. But in those early days, you could have mistaken one for the other. Two planets with the same ingredients, simmering side by side, both with the potential for something extraordinary, and maybe that's what makes Mars's story so bittersweet. It had everything it needed: water, warmth, minerals, energy. It had a head start. And yet, somewhere along the line, it stumbled. But before it dried out, before the last river turned to vapor, it must have been beautiful. Not the kind of beauty we associate with tropical oceans and green forests, but the raw, silent beauty of a young planet figuring itself out. So, when we look at Mars today, dusty, frozen, lonely, we're not just seeing a planet that failed. We're seeing the aftermath of a world that once bloomed. The dry valleys, the ancient lake beds, the mineral veins. They're not signs of emptiness. They're evidence of what once was. Mars didn't always wear red. Once upon a time, it shimmered in shades of blue, whispering through its rivers the same story that Earth still tells today. Where there is water, there is the possibility of life. For life to cook up, you need three key ingredients: water, chemistry, and energy. Mars had all three on the menu. It was like a cosmic kitchen stocked with everything, just waiting for something to start bubbling. Back in its prime, early Mars was not a lifeless wasteland, but a giant planetary experiment in biochemistry, simmering under a pale orange sky, and asking the universe the same question we still ask today: what does it take to make life happen? Let's start with chemistry, because life, no matter how weird it looks, follows the rules of molecules. On Earth, every living thing is built on carbon, that chatty little element that bonds with almost anything, forming the endless chains and rings that make up organic matter. Mars, as we now know from rover discoveries, has plenty of carbon compounds in its soil. These aren't fossils of life, but they're like unopened letters from a time when the planet was chemically active. Scientists have found organic molecules preserved in Martian rocks, rings and chains of carbon that hint the planet wasn't chemically boring. If Mars was once a kitchen, these were the flour and sugar left behind after the meal. Add to that the fact that Mars was never short on other useful ingredients: sulfur, nitrogen, phosphorus, and oxygen, all essential elements for biology, exist in Martian minerals. The planet's volcanic activity would have helped mix them up nicely, spewing gases into the air, baking minerals in heat, and creating chemical gradients across the surface. In fact, volcanoes may have acted like giant natural laboratories, turning simple molecules into more complex ones under the right conditions. And while the phrase lava soup doesn't sound appetizing, in planetary science, it's practically a gourmet environment for chemistry to thrive. Now, life doesn't run on chemistry alone. It needs energy, something to power reactions, drive metabolism, keep the chemical wheels turning. On Earth, that energy often comes from sunlight, but it can also come from the deep, dark underworld of hydrothermal vents, places where hot water meets cold oceans, and minerals spark with electrical potential. Mars, during its wetter days, may have had similar systems. Its volcanic past means there were hot spots where groundwater met magma. Those encounters could have produced warm, mineral-rich environments, perfect incubators for the first biochemical reactions. Even without oceans, Mars had other energy sources to play with. Ultraviolet radiation from the sun bombarded the planet's surface constantly, and while that would fry most modern life in the early days, it might have helped break apart molecules, forming new ones in the process. Lightning, too, may have danced across Martian skies, providing jolts of energy to kickstart reactions. Think of early Mars as the universe's most chaotic chemistry set, messy, violent, and utterly fascinating. Then there's the question of timing. Mars and Earth formed around the same time, roughly 4.5 billion years ago, and for the first few 100 million years, they were both bombarded by asteroids, constantly reshaped and frequently melted. But after the chaos settled, both planets began to cool and stabilize. Earth eventually became home to oceans and life. Mars did too, at least in potential. For hundreds of millions of years, conditions on Mars were just right. Liquid water on the surface, an atmosphere thick enough to hold it, and enough chemical activity to keep things interesting. If life ever emerged on Mars, it might have started simple. Just a few self-replicating molecules tucked away in puddles, mineral pores, or underground niches. On Earth, similar molecules led to RNA, DNA, and cells. On Mars, maybe they started to, but the planet's environment shifted before things could progress. The question isn't just whether life existed there, but whether it had enough time. How long does it take for chemistry to cross the line into biology? 1,000,000 years? 1,000,000,000? Mars had the ingredients, but perhaps it ran out of oven time. One particularly intriguing possibility is that Mars didn't just start its own version of life, it may have shared it. Meteorites from Mars have landed on Earth, launched into space by asteroid impacts that flung Martian rocks across the void. Some scientists believe those rocks might have carried microbes, or at least the building blocks of life between the planets. In other words, life could have started on Mars and then hitchhiked to Earth. If true, it would make us the ultimate cosmic imports. Martian descendants complaining about taxes on a foreign planet. But even if Mars never got past the primordial soup stage, the fact that it had all the ingredients matters enormously. Chemistry isn't shy, it happens wherever it can. The same reactions that once occurred in Martian soils could still be happening underground today, where ice and rock meet in dark, isolated pockets. Without sunlight or surface warmth, these regions could still harbor chemical processes fueled by radiation or mineral reactions. Slow, steady sparks of life's ancient recipe repeating themselves in silence. And let's not forget the minerals that make it all possible. Perchlorates, sulfates, and clays. Things that sound like a grocery list for geologists play crucial roles in stabilizing and protecting organic compounds. Some of these minerals can even act as catalysts, speeding up reactions. Imagine tiny Martian grains acting like microscopic chefs, helping molecules combine in the right way. Over time, such chemistry could accumulate into something remarkable, a network of reactions complex enough to imitate metabolism. Of course, the big question remains: did Mars ever cross the line? Did chemistry on that planet ever take the leap from molecules to microbes? We don't have proof yet, but the evidence keeps whispering yes. Every mineral vein, every trace of organic carbon, every ancient lake bed is another clue. It's as if the planet is trying to tell us, I had the right ingredients. I just needed a little more time. If Mars did manage to spark life, even briefly, that changes everything we know about the universe. It would mean life isn't rare or special. It's inevitable wherever the right chemistry comes together. Mars would go from being our empty red neighbor to our older sibling, the one who tried first but couldn't quite hold on. In the end, that's the beauty of the Martian kitchen story. It reminds us that life doesn't require miracles. It requires opportunity. And, for a while, Mars had plenty. It may have lost its warmth and water long ago, but chemically speaking, it was once a planet alive with potential, a cosmic recipe that came tantalizingly close to success. If life began, did it stay microscopic, or did evolution pull an interplanetary surprise? Maybe tiny Martian microbes became something bigger, smarter, and more ambitious, like us, but with better sunscreen. It's one of the most thrilling questions we can ask about the cosmos. If life ever took root on Mars, could it have evolved into something capable of building, thinking, or even wondering? Or did it stay humble, quietly existing under the surface until the planet itself gave up the game? On Earth, microbes are the unsung heroes of existence. They are the first life forms, the survivors of apocalypse after apocalypse, and the reason we're here at all. Given enough time, energy, and environmental shifts, evolution turned those single-celled pioneers into the parade of complexity that walks, swims, and complains about Mondays today. Mars, at least in its early days, may have had a similar head start. It had water, chemical diversity, and energy, all the key ingredients that make natural selection roll up its sleeves. So, if evolution had the same toolkit, why couldn't it have happened there too? Let's imagine the slow unfolding of Martian evolution. It starts simple. Tiny, carbon-based microbes eking out an existence in mineral-rich puddles or warm, underground aquifers. These microbes might have learned to harvest energy from their environment, perhaps through chemical reactions involving iron or sulfur, the same way some Earth bacteria thrive around volcanic vents. They wouldn't have needed sunlight. Mars' murky skies and dust storms would have made sunbathing difficult anyway. Instead, life could have thrived in the shadows, beneath rocks or inside pores of ancient basalt, protected from radiation and freezing winds. Now, imagine those organisms over millions of years. Mutation after mutation, small advantages accumulating. Maybe one microbe learns to endure drought a little better. Another figures out how to store nutrients longer. Some could even develop protective coatings against radiation, essentially built-in sunscreen made of minerals or pigments. Those traits would spread, and Mars, slowly but surely, might have built an ecosystem of microscopic survivors, each more adapted to the planet's harshness than the last. But what happens when time stretches long enough? On Earth, multicellularity, the leap from single-celled organisms to complex life, happened more than once. It's not a 1 in a billion fluke. If Mars had stable conditions for a few 100 million years, the same evolutionary trick could have been played there too. Picture colonies of Martian microbes forming cooperative networks, sharing resources, building biofilms that began to resemble primitive tissues. Not flesh and bone as we know it, but something alien. Structures made from iron oxides or silica, resilient and efficient. If the Martian environment remained stable long enough, these life forms might have continued evolving, diversifying into niches, some specializing in thermal springs, others burrowing into ice, maybe even a few venturing toward the surface to exploit sunlight during mild periods. The result wouldn't necessarily be creatures we'd recognize. Evolution doesn't care about symmetry or aesthetics. It just makes whatever works. Maybe Martian life grew into colonies of tendril-like organisms that drew energy from chemical gradients in the soil, or mats of bioengineered carpets that expanded across wet plains, soaking up nutrients before retreating underground during dry spells. And if we stretch our imagination just a little further, if we let evolution run wild over billions of years, who's to say intelligence couldn't have emerged? Not humanoid intelligence, but something alien, something suited to the planet's strange rhythms. Maybe creatures that communicated through vibrations in rock or pulses of magnetic fields. Maybe beings that never saw the stars but understood the planet's inner heat like we understand sunlight. If intelligence is simply the universe's way of letting matter understand itself, then Mars had its chance too. Of course, the planet's eventual transformation from wet to dry, from warm to frozen, would have been catastrophic. Evolution favors adaptability, but even the hardiest species can't survive when their entire environment collapses. If Mars's atmosphere thinned and its water vanished, any surface dwellers would have perished. The survivors, if any, would have gone underground, retreating into pockets of warmth beneath the crust. It's possible, in some far-fetched but thrilling scenario, that an advanced Martian biosphere adapted to this new world by becoming subterranean. Entire ecosystems might have developed in caverns heated by geothermal energy, glowing softly in the dark from bioluminescent reactions. Life, quite literally, going underground to avoid extinction. But if Mars ever did harbor a civilization, something beyond microbes, beyond biology as we define it, it would have left traces. Tools, structures, patterns in rock that defy randomness. Yet, after billions of years of erosion, impacts, and dust storms, even the grandest Martian cities could be gone. The surface of Mars is a master at burying history. It's like a planetary time capsule with the label worn off. The question isn't just whether there was intelligent life, but whether any record of it could possibly survive. Maybe that's the universe's cruelest trick. Civilizations might come and go so completely that the only thing left to show they existed is the silence. When we look at the Martian landscape, maybe we're staring at the ruins of an experiment that succeeded for a while, then faded before anyone could know. For all we can tell, the first spark of intelligence in the solar system might not have come from Earth at all. It might have flickered red on a planet that no longer remembers it. And even if Mars never reached that level, if it never produced cities or languages or tools, its potential evolution still teaches us something profound. Evolution doesn't belong to Earth. It's a universal algorithm, a cosmic process that can start anywhere the conditions are right. Mars might have been one roll of those evolutionary dice. Maybe it almost worked. Maybe it did work for a while, and maybe, just maybe, some of its descendants are still there, deep underground, clinging to warmth, whispering chemical secrets into the silence of stone. In the end, whether Mars produced microbes or megacities, its story reminds us that life is not guaranteed, but possibility is everywhere. Evolution is patient. It doesn't need an audience, just time and opportunity. Mars had both once, and that alone makes it one of the most haunting, hopeful places in the solar system. Mars lost its magnetic field about 4 billion years ago, which meant the solar wind had free rein to strip away its atmosphere. Imagine Earth losing its Wi-Fi connection. Except this one deleted oceans, air, and maybe an entire civilization. It was a planetary unplugging, and when the lights went out on Mars, they stayed out. What was once a world of rivers and clouds slowly turned into the frozen red wasteland we know today. The story of how that happened is part science, part tragedy, and entirely cosmic in scale. To understand how Mars met its fate, we have to start deep beneath its crust, in the molten heart of the planet. A planet's magnetic field is born from motion in its core, a swirling sea of molten metal that generates a protective magnetic bubble around it. On Earth, this geomagnetic field shields us from the solar wind, the constant stream of charged particles that the sun hurls into space like an invisible storm. Mars once had that same protection, a magnetic umbrella that kept its atmosphere safe. Then one day, the generator broke. Scientists think Mars's core cooled faster than Earth's because the planet is smaller. When the molten iron in its center began to solidify, the movement slowed, and so did the magnetic field. Without that magnetic barrier, the solar wind started doing what solar wind does best, tearing things apart. It stripped away gas molecules from the upper atmosphere, atom by atom, until Mars' once thick blanket of air became paper thin. Imagine the sun slowly sucking the breath out of a planet. That's what happened here. As the atmosphere faded, so did the pressure. On Earth, our air is thick enough to keep water liquid on the surface, but when the pressure drops too low, water has a choice: evaporate or freeze. On Mars, it did both. The lakes boiled away into vapor, the rivers vanished, and whatever remained froze solid in the ground or at the poles. The planet that once glittered with blue became a dull, rusty red. This wasn't a sudden apocalypse. It was a slow death, centuries stretching into millennia, each one just a little colder, a little drier. If you could fast forward through Martian history, you'd see its skies thinning, its clouds disappearing, and its oceans shrinking into ghostly outlines. If any life had existed on the surface, microbes, vegetation, or perhaps something more advanced, it would have faced an impossible challenge. The ground would have grown toxic with perchlorates, the radiation would have spiked to deadly levels, and temperatures would have plunged below what even the hardiest organism could tolerate. The planet became uninhabitable, one breath at a time. In the solar system, Mars became the cautionary tale of climate gone wrong. Its transformation wasn't the result of carelessness or pollution, it was physics, pure and relentless. Yet, the parallels with Earth's own climate vulnerability are impossible to ignore. A small shift in a planet's balance can mean the difference between habitability and desolation. Mars is what happens when a planet loses its shield, its warmth, and its ability to recycle air and water. It's nature's way of saying, this is what instability looks like. Still, the story doesn't end with loss. The aftermath of Mars' magnetic collapse created one of the most dramatic surface transformations in the solar system. Dust storms became the planet's new weather pattern, roaring across its plains with winds strong enough to reshape dunes and bury landscapes. Without rain to tamp it down, fine particles accumulated over eons, coating everything in red oxide, a global layer of rust that turned Mars into its iconic color. Every grain of that dust is, in a way, a fossil of a wetter world. And then there's the radiation. With no magnetic field or thick atmosphere to protect it, the planet's surface became a target for cosmic rays and solar particles. On Earth, our atmosphere and magnetosphere deflect most of that high-energy assault. On Mars, those rays penetrate straight into the soil, sterilizing the upper layers. It's like the sun switched from nurturing gardener to merciless exterminator. Today, any hypothetical life would have to live deep underground, where the radiation can't reach. But what if something, or someone, was there when it all began to unravel? Imagine a civilization that watched the skies fade from blue to ochre, that saw rivers turn to dust and oceans recede into memory. They might have built shelters underground, tried to preserve what they could of their world, and recorded their history on materials designed to outlast the ages. Maybe those remnants are still buried beneath the surface, encased in layers of sediment, waiting to be found by the next intelligent species to wander by. Us. It's a thought both romantic and eerie. The idea that the story of Martian collapse might be etched somewhere underfoot, written in the silence of stone. NASA's MAVEN spacecraft, which studies Mars's upper atmosphere, has confirmed that this stripping is still happening, albeit at a much slower rate. The solar wind continues to nibble at what's left of the atmosphere, stealing about a quarter pound of gas every second. Over billions of years, that tiny loss added up to everything. The thin veil of air we see now, less than 1% of Earth's atmospheric pressure, is the skeleton of a once vibrant sky. And yet, despite the devastation, Mars endured. It didn't shatter or fall apart. It froze, adapted, and waited. It's the ultimate survivor, albeit a silent one. Beneath its dusty surface lie ice deposits, chemical traces of past climates, and perhaps even pockets of gas that whisper of its former life. Studying them is like opening the autopsy report of a planet, a record of every beat and failure that turned paradise into wasteland. The great Martian climate disaster wasn't just an ending, it was a transformation. Mars didn't die. It changed state. It became the quiet planet next door, a frozen archive of what happens when a world's defenses fall. And while it's easy to think of it as tragic, there's also something profoundly resilient about it. Mars reminds us that even in loss, there's endurance. The same solar wind that erased its air also preserved its surface in exquisite detail, keeping the past intact under layers of soot. If Mars could speak, it might not lament its fall. It might warn us. It might tell us that balance is fragile, that warmth and habitability are fleeting privileges in the cold theater of space. And maybe that's the real legacy of its great disaster. Not a story of failure, but a planetary lesson whispered across the void. A reminder that even the most promising worlds can fade if their hearts grow cold. If an ancient Martian civilization existed, what clues might they have left behind? Maybe fossilized structures, buried technology, or ruins hidden beneath the dust plain. Archaeology meets astrophysics as we imagine finding Martian pyramids, and the skeptical scientists trying not to roll their eyes. Because if Mars ever had builders, storytellers, or even curious toolmakers, the evidence might not be as gone as we think. It might just be sleeping under a few million years' worth of dust. The idea of finding traces of a lost civilization on Mars is the ultimate scientific daydream. It's Indiana Jones in space, with fewer snakes and more solar radiation. But beneath the romance of discovery lies a very serious challenge. Mars is a world that erases itself. Winds sweep across its plains, covering craters and smoothing edges. Meteors pound its surface, rewriting the terrain. Even without water erosion, the fine dust acts like slow-motion sandpaper, grinding everything down. If a Martian civilization existed, its remains would be incredibly faint, like trying to find footprints in a desert after 1,000 storms. Still, faint doesn't mean impossible. On Earth, even the oldest fossils survive because nature, paradoxically, is both destructive and preservative. Lava flows, ice, and sediment have locked away ancient traces of life for billions of years. Mars, with its dry and stable environment, might be even better at preservation. Without tectonic activity to churn the crust or vegetation to reclaim ruins, things on Mars tend to stay put. If something was built there eons ago, be it a city, a monument, or a piece of machinery, it could still be buried intact beneath layers of regolith, waiting for sunlight or a rover's camera to stumble upon it. Let's start with the most basic form of evidence: shapes. When we first sent orbiters to Mars, some of the photos they took lit up the world's imagination. None more so than the Face on Mars, a blurry image from the Viking 1 mission that seemed to show a massive humanoid face staring up from the Cydonia region. It looked deliberate, sculpted, haunting. For a moment, people wondered if it was a Martian monument, perhaps the last gesture of a lost civilization. Later, with higher resolution cameras, it turned out to be just a mesa, a trick of light and shadow. But that moment said something powerful about us. We want to find meaning, to see intention in the randomness of rock. We're pattern-seeking creatures with cosmic-sized curiosity. But what if, one day, one of those patterns turns out to be real? It wouldn't have to be a colossal statue or an alien city grid, just one artifact, one unnatural arrangement of materials that couldn't have formed by geological chance. Maybe a series of geometric formations carved into bedrock, or a metallic anomaly buried where no natural metal deposits should exist. Perhaps something as simple as a repeating pattern etched into stone, too regular to be nature's doing. That's the kind of find that would change everything. And here's the catch: such discoveries might already be in our archives, unnoticed. Our rovers and orbiters have sent back millions of images, and human eyes have scanned only a fraction. AI systems now help catalog and analyze them, but even machines are trained on what we think is natural or artificial. If something truly alien exists, it might not even register as significant because it doesn't fit our definitions. Maybe the fossilized remnants of a Martian civilization aren't hidden. Maybe they're sitting right in our datasets, dismissed as weird rocks. The most realistic evidence wouldn't look like temples or machinery anyway. It would look biological. Fossilized microbes, stromatolite-like formations, or strange mineral patterns hinting at once living structures. If Martian life ever achieved complexity, even modestly, it might have left biosignatures, chemical imprints of metabolism, fossilized cells trapped in ancient mud, or isotopic ratios that scream, life was here. Those are the kinds of clues planetary scientists are hunting, brushing through spectral data the way archaeologists brush dust off bone. But let's dare to think bigger. What if there was technology? Not shiny spaceships or laser guns, but subtle, decayed remnants of tools or construction. On Earth, human-made metals and alloys eventually corrode, plastics degrade, and cities crumble. After a few million years, most traces of human civilization would vanish, leaving only the most resilient materials, stone, ceramics, and radioactive isotopes, as proof we were ever here. On Mars, the process would be slower, but just as thorough. A Martian city could have collapsed long before Earth even cooled from its molten youth, leaving behind little more than chemically altered minerals, microscopic fragments of alloys, or oddly shaped formations that tell their story only through their geometry. If such relics exist, finding them would take more than luck. It would take context. You'd need to prove that their composition doesn't match Martian geology, that their placement defies randomness, and that their structure hints at purpose. It would be like solving a planetary crime scene where the suspect is time itself. Every piece of evidence would have to be weighed against the possibility of natural explanation. The burden of proof wouldn't just be high, it would be astronomical. And even if such evidence was found, there's the human factor. Scientists are trained skeptics, allergic to jumping to conclusions. The first response wouldn't be, "We found aliens." It would be, "Are we sure this isn't a rock that looks suspiciously like a coffee table?" That skepticism is crucial. It's what keeps discovery from collapsing into fantasy. But sometimes skepticism and wonder can coexist. Science thrives in that tension. The push and pull between what we know and what we dare to imagine. If Mars once had civilization, it might not be gone. It might just be hidden in plain sight. Beneath the dust, inside the rocks, encoded in isotopes or mineral alignments, waiting for the right pair of eyes, or the right rover to notice. The fossils of thought, the architecture of intention, could still be there, silent and undisturbed for eons. When you think about it, every mission to Mars is a kind of archaeological dig across time. Each drill sample and image isn't just a study of geology, it's a question whispered into the soil. Was anyone here before us? Maybe the planet won't answer directly. Maybe the fossils in the dust will be too subtle, too faint. But even if all we find are hints, patterns, possibilities, shadows of what might have been, That's enough to keep the story alive. Because sometimes what we don't find is what keeps us looking. And on Mars, where dust covers everything and silence lasts forever, that's the most human thing we can do. Keep digging, keep wondering, keep listening to the wind over the plains, hoping it's carrying the faint echo of something that once was. Remember the famous photo that looked like a giant face staring back from the Martian surface? Turns out it was just a rock formation playing cosmic peekaboo. Back in 1976, when NASA's Viking 1 orbiter snapped that grainy black and white image of the Cydonia region, the world collectively gasped. There it was, an unmistakable face. Eyes, nose, mouth, even what looked like a crown of ridges. For a moment, it felt like Mars had sent us a postcard saying, "Yes, we're home. Sorry about the mess." That one picture changed everything. Newspapers splashed it across their front pages, talk shows debated it, and scientists quietly braced themselves for the incoming tidal wave of speculation. To many, it wasn't just a rock, it was proof. Proof that someone, or something, had carved a monument in their own likeness, perhaps as a message to whoever might come next. For years, the face on Mars became the poster child of cosmic mystery, sitting comfortably between the Nazca lines and the pyramids in humanity's list of unsolved ancient wonders. But when NASA sent newer, sharper cameras decades later, the mystery crumbled faster than a cookie in a sandstorm. The Mars Global Surveyor in '98 revealed the truth. No sculpted masterpiece, no alien Michelangelo, just a mesa, a flat-topped hill lit dramatically by the angle of the sun. The shadows had done all the work, turning geology into a galactic Rorschach test. Under different lighting, the face vanished, replaced by nothing more than ridges and valleys. Mars wasn't looking back at us. We were just seeing ourselves in its dust. And that, as it turns out, says more about us than it does about Mars. Humans are professional pattern seekers. Our brains evolved to find meaning in chaos, to spot shapes, faces, and potential threats in the noise of the natural world. It's the same instinct that lets you see animals in clouds or monsters in the dark. It's also why toast sometimes looks like Elvis. On Earth, this skill helped us survive. On Mars, it makes us dream. This phenomenon even has a name: pareidolia. It's the brain's tendency to impose familiar patterns, especially faces, onto random stimuli. We're hardwired for it because recognizing faces quickly was once a matter of life or death. Back in our prehistoric days, mistaking a rock for a predator might have been embarrassing, but mistaking a predator for a rock was fatal. So evolution wired us to err on the side of imagination. Fast forward a few million years, and that instinct hasn't gone away. It's just turned toward the stars. The face on Mars wasn't the only optical illusion to capture imaginations. Similar features popped up elsewhere. The Martian pyramid nearby, hills shaped vaguely like animals, even boulders that resembled ancient statues. Each new image sparked excitement among the alien ruins faithful, and each time scientists rolled out the same explanation: lighting, erosion, and coincidence. But explanations rarely compete well with wonder. The truth is, we want the universe to be filled with messages, monuments, and meaning. A lifeless landscape feels lonely. A carved face feels like company. Still, that doesn't mean the phenomenon is foolish. It's profoundly human. Pareidolia is, in a strange way, a reflection of our optimism. It's our subconscious whispering, we can't be alone. When we stare at distant planets and see familiarity, we're projecting ourselves into the cosmos. We're saying, maybe someone out there thought, felt, and dreamed like us. Even when the science says just rocks, the hope persists. And sometimes that hope leads to real discovery. After all, curiosity has to start somewhere. Many groundbreaking findings in science began as misinterpretations that led to better questions. The face on Mars made people care about Mars again. It revived public interest in space exploration during a lull, inspiring generations of amateur astronomers, dreamers, and even a few future planetary scientists. In that sense, the illusion did more good than harm. It reminded us how deeply we want to connect. Psychologists have studied how pareidolia operates in the brain. When we look at ambiguous shapes, the visual cortex fires up in the same way it does when we see a real face. That's why the face on Mars didn't just look like a face, it felt like one. Our brains didn't just see the image, they recognized emotion, personality, even intent. That's how powerful our internal pattern engines are. Mars didn't need to wink. We did it for it. There's also something poetic about this tendency. For centuries, humans have gazed at the moon and imagined figures. The man in the moon, the rabbit, the face. We've drawn gods and monsters from constellations. Seeing the face on Mars was just the next step in that ancient story. It was the universe giving us a blank page, and we doodled on it. Today, high-resolution images show every ridge and crater of Cydonia in crystal clarity. The mystery is gone, but the magic lingers, because while we now know it's a mesa, we can't quite look at it without remembering the thrill of that first blurry photo. The feeling that maybe, just maybe, another species once looked back from those plains. Science can debunk, but it can't erase wonder. And perhaps that's the lesson Mars keeps teaching us. Every time we project meaning onto its surface, we're really learning about our own minds, their strengths, their quirks, their relentless need to connect the dots. The face on Mars wasn't a cosmic hoax, it was a mirror, reflecting our desire for companionship in a vast, indifferent universe. So next time you see a face in the clouds or a figure in the Martian dust, don't roll your eyes. Smile instead. That's the brain doing what it does best, finding stories in the static, turning randomness into meaning. On a lonely red planet millions of kilometers away, a pile of rocks made us dream of neighbors. That's not a mistake of perception. That's proof of imagination. And imagination, more than any carved monument, is what makes us truly cosmic. What if Martian life didn't vanish, but escaped underground? Some scientists think microbes could still be hiding deep below, protected from radiation and dryness. Maybe they evolved in secret, forming a whole subterranean world. Think of it as Mars's version of we don't talk about surface life. It's a fascinating twist on the old narrative. Maybe the story of Mars isn't one of extinction, but of adaptation. The surface became hostile, a frozen desert drenched in ultraviolet light, but underground, the planet might still be alive in whispers. Instead of a dead world, Mars could be a quiet one, with life that learned to survive where the sunlight cannot reach. Beneath the Martian crust lies an environment that seems almost purpose-built for persistence. Temperatures rise as you go deeper. Ice becomes liquid in some layers, and chemical reactions provide potential sources of energy. It's dark, yes, but not necessarily dead. On Earth, we've found entire ecosystems thriving far below the surface, in caves, aquifers, and even within the cracks of rocks miles deep. These organisms, known as endoliths, don't need sunlight. They survive on chemistry, feeding off minerals, hydrogen, and methane. To them, surface life is the weird, risky stuff. If Earth's underground biosphere is any clue, Mars could easily have its own hidden population of microbial tenants. Scientists have been chasing hints of this possibility for decades. One of the most tantalizing clues came from methane, a simple gas that, on Earth, is often produced by life. Mars has methane, and it behaves strangely. It appears in bursts, vanishes, and then reappears again, almost like the planet is breathing. Some suggest it could come from geological activity, gas released by rock and water reactions. But others whisper that it might come from something alive, trapped deep below. The problem is, no one knows for sure. Mars, ever the dramatic neighbor, gives us just enough data to keep us guessing. Imagine what that hidden ecosystem might look like. Not forests or oceans, but networks of microbes forming colonies inside mineral veins. Their lives measured in millennia rather than days. They could exist in liquid water trapped in salty brines, surviving off chemical gradients, the difference between oxidized and reduced compounds. On Earth, similar life forms exist around hydrothermal vents or inside deep mines, where sunlight hasn't reached in millions of years. Mars might have parallel conditions, though colder and more extreme. And what if those microbes didn't just survive? They evolved. Evolution doesn't stop just because it's underground. Over billions of years, Martian life could have diversified, adapted to the underground geography, developed symbiotic systems, even rudimentary communication. Maybe they built biological networks, like microbial cities embedded in rock pores, exchanging chemicals the way we exchange information. We might never see them with our eyes, but if you could shrink yourself down and walk through the Martian subsurface, perhaps you'd find glowing colonies that pulse faintly with life's rhythm. Tiny, bioluminescent signatures of survival. The concept of underground life on Mars isn't just science fiction, it's increasingly considered the most realistic scenario for habitability. The European Space Agency's ExoMars mission and NASA's Perseverance rover both carry instruments designed to look for chemical fingerprints that might drift up from below. They're searching for traces of organic molecules, unusual isotopic ratios, or gases that suggest something more than chemistry is at work. If we ever find life on Mars, odds are it won't be waving at the camera. It'll be clinging to the underside of a rock or hiding in a crack that hasn't seen light in billions of years. And then there's the question of independence. If Mars does host living organisms, are they related to us? Or are they a completely separate origin story, a second Genesis? It's a chilling thought. Two worlds, side by side, both giving rise to life independently. That would mean life isn't rare at all. It's just what matter does when given enough time and chemistry. Mars's underground realm could be proof that biology doesn't need Earth's exact recipe to get started. It just needs a little shelter and a stubborn attitude. Of course, if that's true, it raises the possibility that life never really left Mars at all. It just moved to a different address. The surface became too harsh, so evolution took the sensible route. Dig in and wait it out. What we see as a barren planet might actually be a living one, just hidden under layers of rock and silence. Some researchers even suggest that Mars' deep subsurface could extend its habitable zones kilometers down, insulated from radiation and temperature swings. In those depths, geothermal heat could keep pockets of liquid water stable, creating mini oases in an otherwise frozen crust. There's even speculation about something more dramatic. What if life down there isn't just microbial? What if evolution, in its slow and sneaky way, took another step? Over billions of years, even tiny variations could add up to complex adaptations. Not aliens, as we imagine them, no bug-eyed creatures in chrome suits, but multicellular organisms uniquely suited to darkness, pressure, and mineral-rich surroundings. Perhaps they move slowly, responding to chemical signals, pulsing through liquid-filled fissures like veins of living rock. It's unlikely, but not impossible, and that's what keeps scientists digging, literally and figuratively. Every drill sample, every radar scan, every methane reading is a small excavation of Mars' buried story. We might never see these hypothetical creatures, but even microbial evidence would be monumental. It would tell us that life isn't fragile. It's versatile. It doesn't quit when the lights go out. It simply changes form and keeps going. And perhaps that's the alien parallel Mars offers us. Not just another life form, but another philosophy of existence. While Earth's biosphere exploded outward into diversity and light, Mars's may have turned inward, folding its ecosystem into the safety of rock. Two worlds, two directions. One filled with forests and oceans, the other with silence and stone. But both, possibly, alive. So the next time you look at a picture of Mars, its barren plains, its dusty hills, remember, what we see might not be the whole planet. Beneath that rusted crust, miles below where our cameras can see, there could be a civilization of microbes still thriving in the dark, keeping the flame of life alive in a world that forgot the sun. If so, then Mars isn't dead. It's just waiting for us to dig a little deeper and finally say hello. Now, humans show up, planting flags and rovers, taking selfies on soil that might have once been someone else's backyard. The irony writes itself. After centuries of wondering if aliens would ever visit us, we became the aliens. Metallic invaders rolling across the Martian surface, leaving tracks in dust that may have already recorded a different civilization's story long before ours began. If Mars ever had life, intelligent or not, humanity didn't just arrive late to the party. We showed up after the music stopped, the lights went out, and the host turned to dust. When the first robotic explorers touched down on Mars, they brought with them more than cameras and scientific instruments. They brought curiosity, ambition, and, unintentionally, contamination. We sterilized the rovers, of course, heat-treated, scrubbed, sealed in near-perfect conditions. But nothing humans make is entirely free of us. The first Martian soil samples we disturbed might have been the first contact between two biologies, Earth's microscopic stowaways, and whatever, if anything, still lingers there. It's an unsettling thought. We worry about alien invasions, but if you zoom out, humanity has already launched one. It's strange to think of us as the outsiders. We're used to imagining ourselves as the protagonists of cosmic history, the explorers discovering new worlds. But on Mars, we're the newcomers, the uninvited guests kicking up ancient dust and asking questions no one left to answer. If Mars ever hosted life, we're walking across its grave, cheerfully snapping photos and naming rocks. Even if the planet is truly barren, there's something humbling in realizing how casually we impose our presence. We land, we claim, we probe, and we measure. In human terms, that's science. In cosmic terms, it's trespassing with good intentions. Every mission to Mars, Viking, Pathfinder, Spirit, Opportunity, Curiosity, Perseverance, is part of our species' long campaign to uncover the planet's secrets. But think about how we look from Mars' perspective. Machines crawling over its skin, drilling holes, digging trenches, leaving tire marks and scorch spots. If the planet had memory, it might not know what to make of us. We arrive not as conquerors, but as curious vandals, dismantling the past to understand it. It's the interplanetary version of archaeology, except the ruins may be geological instead of cultural, or both, depending on what we eventually find. There's a peculiar arrogance in assuming we're the first intelligent beings to walk those plains. Every scoop of soil we lift, every crater we name after ourselves, is an act of cosmic confidence. We map Mars the way cartographers once mapped Earth's new continents, as though naming grants ownership. Yet there's a quiet irony behind that confidence. We could be explorers stepping into a museum that's been closed for billions of years, brushing dust off exhibits we don't recognize. Our instruments may one day stumble upon something that doesn't fit, an artifact, a chemical anomaly, a fossilized imprint, and suddenly realize we were never the first to arrive, only the latest to rediscover what was lost. Even our technology betrays our naivety. We send rovers with cameras that gaze at rocks like tourists at ruins, searching for signs of life but often photographing our own tracks. Perseverance, for example, carries messages from Earth engraved on its body, a plaque, a symbol, and the names of millions of people etched into microchips. It's a touching gesture, but also a cosmic calling card. We're essentially leaving behind business cards that read, "Humans were here." The irony, of course, is that if there was once a Martian civilization, it might have done the same. Left inscriptions, signals, or artifacts for posterity, none of which we can yet decipher. We're both civilizations separated by time, each leaving messages in the void, neither able to read the other's language. But beneath all the irony lies something beautiful. Our arrival marks the moment two worlds finally meet. For billions of years, Earth and Mars orbited the same star like estranged siblings, sharing sunlight but never speaking. When we sent our first spacecraft, we broke that silence. For the first time in cosmic history, one planet reached out to another. That's extraordinary, even if it took us a few billion years to get the courage. It's a reminder that exploration isn't just about curiosity, it's about connection. We're bridging the distance between two worlds, even if one of them might already be gone. Of course, our arrival also raises a moral question. What do we owe a dead planet? If Mars is lifeless, do we have the right to reshape it, to terraform, colonize, and fill it with Earth's biology? Some argue it's humanity's destiny to spread, to give Mars the life it lost. Others see that as cosmic arrogance, the act of rewriting another world's history to make it resemble our own. It's a philosophical tug-of-war between reverence and ambition. On one side, Mars as sacred relic, on the other, Mars as blank canvas. And then there's the unsettling possibility that it isn't blank at all. If there is life underground, if microbial ecosystems still pulse in the planet's depths, our arrival could be the beginning of their end. Introducing Earth organisms could destroy whatever fragile biochemistry still exists there. We could become the agents of extinction for species that have survived billions of years in silence. The first time humanity meets alien life, the encounter might not be one of wonder, but of accidental extermination. Perhaps that's the ultimate irony. We journeyed across space to find company, but our very presence might erase it. We came to learn from Mars, and Mars might end up teaching us humility. Every rover, every drone, every astronaut that sets foot there will face the same unspoken question. Are we explorers or intruders? In the end, Earthlings arrive late isn't just about timing, it's about perspective. We're late to understand that we're part of a much larger story, one written in dust and silence. Maybe Mars was once home to life, or maybe it was always empty. Either way, it has waited patiently while we learned how to look up, build rockets, and ask questions big enough to echo between planets. So here we are, latecomers to a world that might have lived and died before we were even imagined. Our rovers roll forward, their tracks marking the beginning of a new chapter in Martian history. Whether we're the first visitors or the latest inheritors, one thing is certain. Mars doesn't belong to us. We belong to the same cosmos that shaped it, two worlds bound by the same star, each carrying the echoes of life, one noisy, one silent, both waiting to be understood. What if the ancient Martians left behind signals, engraved stones, geometric patterns, or something written in dust that only makes sense from orbit? Maybe we've already seen them, but shrugged it off as just rocks. After all, every great mystery in science begins with something dismissed too quickly. Perhaps Mars has been whispering all along, and we've mistaken the whispers for wind. It's a compelling thought that across the endless plains and ridges of the red planet, something intentional lies hidden in plain sight. Not the grand, melodramatic alien monuments of Hollywood imagination, but small, deliberate imprints, a symmetry here, a pattern there, arranged by hands or minds that no longer exist. The planet's silence could be less about absence and more about translation. We're reading the wrong language, looking for sentences when the message might be in geometry. If any intelligent beings ever walked Mars, they would have faced the same problem we face now: how to speak across time. How to say, "We were here," in a way that would outlast erosion, atmosphere loss, and oblivion, On Earth, we build monuments, carve stone, send messages into space. But Mars? Its air is thin, its winds relentless, its seasons brutal. Anything fragile would have vanished long ago. So, if something endures, it would have to be carved into the bones of the planet itself. That's why scientists and dreamers alike have studied the planet's strange geometric features for decades. Vast hexagonal mesas, triangular plateaus, patterns that look almost engineered. Most, of course, can be explained by geology, erosion, impact cratering, the random poetry of nature. But once in a while, a formation appears that seems too deliberate, too neat, too suggestive. And the question arises, could these be messages written not in ink, but in landscape? It sounds fanciful until you realize that nature rarely makes perfect geometry without help. Straight lines, right angles, evenly spaced ridges. These are the fingerprints of design, or at least the illusion of it. The Nazca lines in Peru taught us that immense designs can only be seen from above, invisible to those standing on the ground. If an ancient Martian civilization had the capability, maybe they too rode across their planet's surface, not to be seen by themselves, but by whoever might come next. And now, billions of years later, our satellites skim the sky, capturing those messages pixel by pixel, images we might already possess but don't yet understand. Consider the idea of a planetary time capsule. If you were an intelligent species watching your world crumble, your atmosphere fading, your oceans retreating, what would you do to ensure you weren't forgotten? You might record your knowledge in something indestructible. Maybe etch mathematical constants into stone, trace planetary maps into the ground, or create vast patterns whose precision screams purpose. A civilization that foresaw its own end might not build monuments for worship, but markers for recognition, evidence meant not to impress but to endure. And yet, what if the problem isn't that we haven't found such messages? It's that we can't recognize them. Our minds are tuned to human expression, to our alphabets, our logic, our aesthetics. An alien civilization, even one that evolved in the same solar system, might think and communicate in entirely different modes. Their writing could be topographical. Their records could be encoded in mineral layers, magnetic alignments, or even in patterns of isotopes. To us, it would look like random geology. To them, it would be the sum of their history. We could be staring directly at the Martian equivalent of a library, mistaking it for dirt. It's an uncomfortable possibility, that we are too human to see what's truly there. The universe doesn't owe us familiarity. Intelligence elsewhere may not share our shapes, our tools, or our logic. What we call rocks might have been arranged by minds that never drew with hands, or thought in images, or even used sight. The Martian past, if it exists, might be written in codes we don't yet know how to read. Of course, skeptics point out that such speculation borders on wishful thinking, and they're right to be cautious. The history of exploration is full of people seeing meaning where there is none. Faces in craters, cities in shadows, patterns in noise. But here's the paradox. That same imaginative impulse is what drives discovery. Without curiosity, we'd never look closer. Every dismissed anomaly, every just a rock is a potential breakthrough waiting for the right question. Science doesn't advance by accepting everything. It advances by doubting just enough. Modern Mars missions carry technology far more capable than the Viking cameras of the 1970s. High-resolution imaging, ground-penetrating radar, and spectroscopy now allow us to see beneath the surface, revealing buried layers of ancient activity. We've already found signs of past riverbeds, mineral veins, and sedimentary layers that tell a story of a once dynamic world. But what if among those layers lies a deliberate design, a structure too regular to be coincidence, a spatial pattern that defies random formation? One image could change everything, rewriting not just Martian history, but humanity's understanding of our place in the solar system. If we ever do find such a message, decoding it would be the greatest intellectual challenge in history. Imagine a communication written across an entire planet, not in words but in terrain. What would it say? Maybe something humble. We lived, we loved, we wondered. Or perhaps something purely scientific, a record of knowledge meant to outlast time itself. Or maybe, like us, they weren't trying to send a message at all. Maybe they just left behind patterns as a byproduct of their civilization, never imagining that anyone, or anything, would one day look down from orbit and wonder. And so, we keep scanning, keep mapping, keep puzzling over Martian anomalies. The more we study, the more the line blurs between science and imagination. Because until we know for sure, every rock, ridge, and shadow is a possibility. Maybe the real message from the Martian past isn't carved into stone, but into our own instincts, the need to look for meaning, to connect, to listen. Perhaps that's the greatest legacy Mars could leave us, not an answer, but a question that refuses to die. A reminder that sometimes what we call silence is just a message spoken in a dialect of time we haven't learned to translate yet. It's easy to dream up Martian cities and forgotten empires, but science demands evidence. We'll explore how researchers balance wild ideas with real data, because in science, imagination is the appetizer, not the meal. If Mars has taught humanity anything, it's that wonder and skepticism are not enemies, they're dance partners. One leads with inspiration, the other follows with analysis. The trick is not letting one step on the other's toes. Every great discovery in science begins as a question that sounds ridiculous, until it isn't. So, when we imagine ancient civilizations or hidden biospheres on Mars, it's not about believing blindly. It's about daring to ask, could this be true? And then working methodically to find out. Science, at its core, is disciplined curiosity. It's the art of dreaming responsibly. The researchers studying Mars don't start by assuming anything. They start with data, and then they build hypotheses that stretch toward the unknown but stay tethered to the evidence. The tension between those two, data and dream, is where progress happens. Without imagination, we'd never ask bold questions. Without evidence, we'd never know which answers matter. Mars has been a masterclass in this balance. Take for example, the famous Martian canals of the late 19th century. When Italian astronomer Giovanni Schiaparelli observed Mars through his telescope, he described seeing canali, channels etched across the planet's surface. The term was mistranslated into English as canals, and suddenly the world imagined vast irrigation systems built by intelligent beings. The idea of Martian engineers tending dying seas captured the public's imagination. Books were written, artists painted maps, and even scientists entertained the possibility of life. Then, as technology improved, the dream dissolved. The canals were optical illusions, tricks of the eye caused by low-resolution optics and human expectation. Mars had fooled us, but also inspired us. That moment of error pushed astronomy forward, motivating better telescopes and more rigorous methods. That's how science works. Every mistake sharpens the next question. Every illusion teaches us how to look again. The face on Mars did the same decades later. It wasn't evidence of aliens, but it reminded us how easily the human mind sees patterns it wants to see. Instead of dismissing the fascination outright, researchers turned it into a teachable moment, a study in perception, psychology, and how data can change depending on perspective. Imagination sparked the interest. Evidence set it straight. Today, Mars research thrives on that balance. Scientists know they must hold two opposing ideas at once, that Mars could be lifeless and that it could surprise us. The excitement lies in not knowing. When rovers like Curiosity or Perseverance uncover unexpected minerals or chemical traces, researchers must decide, is this life's fingerprint or just chemistry playing tricks again? The scientific process is slow precisely because it resists jumping to conclusions. It's about building layers of proof thick enough to withstand scrutiny. But make no mistake, speculation is essential. Without it, there would be no missions, no rovers, no telescopes trained on the red planet at all. Before there were robots on Mars, there were poets and thinkers who imagined it. Those early dreams of canals, cities, and alien inhabitants may have been scientifically wrong, but they were emotionally right. They made people care. And caring is what funds research, drives innovation, and keeps the questions alive when the answers are frustratingly far away. In modern planetary science, speculation wears a lab coat. Researchers use simulations, geological modeling, and machine learning to test the boundaries of what might be possible. They ask questions like, how long could Mars have held liquid water? Or, what chemical combinations could mimic biological signatures? These aren't idle curiosities. They're structured guesses, experiments built to challenge reality. Science, at its best, gives imagination rules to play by. For example, when methane was detected on Mars, scientists didn't immediately cry, life. They built models to see whether geological processes, like serpentinization, where rock and water react to produce gas, could explain it instead. Every hypothesis gets a partner in doubt. That's the essence of responsible speculation, being open to wonder while fully expecting disappointment. Even the search for ancient civilizations falls under this discipline. It's not that scientists are unwilling to consider it, it's that extraordinary claims require extraordinary evidence. Finding a geometric formation or a metallic anomaly is exciting, but to prove it's artificial, researchers would need to rule out every natural explanation first. The default stance isn't cynicism, it's caution. After all, Mars has fooled us before. It's a planet with a flair for looking mysterious, then turning around and saying, "Relax, I'm just geology." Yet, there's something beautifully stubborn about humanity's persistence. we keep dreaming anyway. We build orbiters that map the entire planet in exquisite detail, rovers that read the chemistry of ancient rocks, and landers that listen for quakes beneath the crust. Each mission is a question flung into the void. What if? The answers are rarely dramatic, but every piece of data adds a brushstroke to the grand portrait of Mars. Over time, what was once speculation becomes knowledge. The line between science and science fiction is thinner than most people think. Many technologies we now take for granted, satellites, space stations, even the concept of terraforming, began as speculative ideas. The only difference is that scientists have to prove their dreams, while storytellers just have to imagine them convincingly. Both are vital to human progress. The scientist builds the rocket. The dreamer decides where to fly it. So, when we imagine Martian cities, fossils, or messages carved in the dust, we're not betraying science. We're honoring its spirit. The universe doesn't hand out discoveries. It hides them behind endless what-ifs. Mars especially demands that we dream big but verify harder. Because if we ever do find proof of life, or lost civilizations there, we'll know it wasn't luck. It will be the result of centuries of disciplined curiosity, a partnership between imagination and reason. In the end, science isn't about killing wonder, it's about refining it. It teaches us that speculation is not the opposite of truth, it's the seed of it. Every rover wheel that turns, every camera that clicks, every theory that fails brings us one step closer to the real story of Mars. And until we know that story, speculation is the song we hum while we dig through the dust, dreaming of what might still be waiting beneath. Even if there was never a Martian civilization, Mars still teaches us a powerful story. Planets can go from paradise to wasteland fast. Think of it as a planetary warning label that says, "Keep atmosphere on at all times." It's easy to look at Mars as a distant curiosity, a cold red marble hanging in the night sky. But the truth is, Mars is a mirror, and not a flattering one. It shows us what happens when a planet loses its balance. Long ago, Mars may have been alive with water and potential, a younger sibling of Earth that started with promise and ended in silence. The transformation from wet and warm to dry and frozen is more than a cosmic tragedy. It's a cautionary tale. Because what happened to Mars could, under the wrong conditions, happen here. When we study Mars, we're really studying ourselves. Its barren landscape isn't just a scientific puzzle, it's a fossilized warning. Once, the planet may have had rivers wider than the Nile and lakes deeper than the Great Lakes combined. Today, it's a wasteland where the wind carves shapes into sand dunes that no longer remember what water feels like. And the reason for that change lies in the delicate interplay of atmosphere, magnetism, and time. The same forces that keep Earth habitable now. Mars lost its magnetic field, the invisible shield that deflects solar radiation and helps preserve an atmosphere. Once that field collapsed, the sun began stripping the air away molecule by molecule. Without air, water couldn't stay liquid, and without water, everything that depended on it, potential ecosystems, climates, and maybe even civilizations, collapsed. It's easy to shrug off that story as something that happened out there. But the physics don't care about distance. Planetary stability is a fragile gift. The thin blue line of atmosphere above our heads is all that separates us from the cold, sterile void. Mars reminds us that the boundary between paradise and desolation can be thinner than we'd like to believe. Our planet's protective systems, its magnetic field, ozone layer, and climate regulation aren't permanent features. They're products of dynamic processes that can change, sometimes catastrophically. Mars is proof that a planet doesn't have to explode to die. It just has to stop protecting itself. This lesson hits especially close to home in an age when Earth's climate is shifting faster than ever before. We've long treated the atmosphere as an endless sink for carbon and heat, assuming that no matter what we do, Earth will keep adjusting. But Mars stands as a reminder that atmospheres are finite. Once they're lost or altered beyond a certain point, recovery becomes nearly impossible. You don't get a second chance at planetary habitability. There's no undo button for atmospheric collapse. But Mars also teaches resilience. Even after billions of years of decay, it's still there, frozen, scarred, yet enduring. The planet didn't vanish. It adapted to new conditions. It reminds us that change is inevitable, but survival depends on how we respond. Earth, unlike Mars, still has its magnetic field, still has oceans, still has life. The question is whether we can keep those advantages or let them slip away through neglect and hubris. If you zoom out far enough, the difference between Mars and Earth looks like a simple case of luck and timing. Mars cooled faster, lost its molten core sooner, and with it, its magnetic field. But luck isn't a strategy. Earth's shield won't last forever either. The core will eventually solidify, the field will fade, and our atmosphere will begin to drift away. It's an inevitable part of planetary aging, but that's billions of years off. Enough time for us to learn, adapt, and maybe even extend our planet's lifespan. Studying Mars helps us understand how to do that. We can trace its geological scars like a planetary autopsy. The dried riverbeds, the sediment layers, the polar ice caps, all are pieces of evidence in a story about loss. Scientists can reconstruct how quickly Mars cooled, how its air thinned, and how its water vanished. In doing so, we learn how fragile planetary climates are and how interconnected every system becomes. Mars's demise wasn't caused by one event. It was a chain reaction. Lose the magnetic field, you lose the air. Lose the air, you lose the water. Lose the water, and you lose everything that depends on it. It's a domino effect on a planetary scale. There's another, subtler lesson here. The value of stewardship. Earth is not indestructible. It's maintainable. Our technology, our cities, our progress all rely on an environment that remains stable. Mars shows us what happens when stability is lost. It's not fire and brimstone. It's slow suffocation. A world that once may have glistened with lakes turns into a rusting tomb. If that doesn't make us a little more careful about our own atmosphere, nothing will. Even so, Mars offers hope as much as it offers warning. It shows that planets, even dead ones, still have stories worth listening to. Its frozen poles still hide water. Its crust still hums with faint seismic tremors, and its soil still contains the chemical ingredients of life. In studying Mars, we're reminded that life doesn't need perfection. It needs opportunity. Mars lost its chance, but it left us a guidebook on how not to follow. And perhaps that's the greatest lesson of all, that awareness is survival. We don't have to repeat Mars's mistakes because we can read them written in stone. Every rover, every orbiter, every drill sample is a page in that story, a planetary diary written in dust and silence. The more we study it, the more we realize that Mars isn't just a world that failed. It's a teacher, a planetary mentor reminding us that habitability is not a guarantee, but a responsibility. So, when you look up at Mars glowing red in the night sky, don't just see a world long dead. See a warning label floating in the dark, its message as clear as the sunrise. Protect your air, cherish your water, and don't take your blue skies for granted. Mars didn't die suddenly. It simply stopped keeping house. Let's hope we're better at maintenance. If Mars once had life, even simple microbes, it means the universe might be teeming with worlds that tried, and maybe failed, to build their own civilizations. This chapter widens the lens to ask what that means for us, as a young species still learning to keep our home intact. The search for Martian life isn't really about Mars. It's about context. It's about finding out whether Earth is a one-time fluke or part of a repeating cosmic pattern. If even one other world in our own solar system hosted life, it would mean that biology isn't some freak cosmic accident. It's a habit of the universe. And that realization would shake our understanding of existence to its core. Because if life happened twice, so close together, then it probably happened everywhere. Think of it this way. For billions of years, the universe has been running the same chemical experiment over and over on countless planets and moons. Sometimes the conditions fail. Too hot, too cold, too sterile. But once in a while, the mixture bubbles and something extraordinary happens. Matter learns to replicate itself. Atoms organize into cells, cells into organisms, organisms into minds capable of wondering how it all began. If Mars once hosted even the simplest microbes, then it means the universe doesn't just tolerate life. It encourages it. That idea turns our lonely blue planet into part of a much bigger family tree. Mars would be our cosmic cousin, an elder sibling that maybe didn't make it as far, but proved it was possible. And if Mars had life, then surely Europa, Enceladus, or some exoplanet orbiting a distant sun might have it too. The discovery wouldn't just expand our map of the cosmos, it would expand our sense of belonging. We wouldn't be the center of creation anymore, just one node in a vast biological network spanning light years. It's almost funny to think that the spark that might connect us to this cosmic family could come from a few fossilized microbes frozen in Martian rock. But that's all it would take. A single cell, a single trace of ancient metabolism, would be the loudest message ever heard in science. We are not alone. And yet, it would also come with a sobering echo. We are not guaranteed to survive, because if Mars once had life and lost it, that means civilizations, or even biospheres, can fail. It means planets can start off promising and end up quiet. The galaxy may be full of worlds that bloomed for a time, only to fade back into silence. If we could visit them all, maybe we'd find fossils of ambition everywhere, traces of species that reached for the stars and fell short. Mars, in that sense, might not be our only cosmic cousin. It could be our cautionary ancestor. The more we look, the more evidence we find that life-friendly worlds might not be rare. In recent years, astronomers have discovered thousands of exoplanets, many of them Earth-sized and orbiting within the habitable zones of their stars. Statistically, it's almost impossible that Earth is unique. Somewhere out there are oceans, clouds, and atmospheres full of potential. Maybe some are just beginning their journey, microbes stirring in warm puddles. Others might have reached their golden age of civilization, while still others are already gone, their ruins buried beneath alien sands. The cosmos could be a graveyard and a nursery at the same time. This search for our cosmic cousins isn't just about curiosity, it's about perspective. Finding life elsewhere forces us to look at our own planet differently. We spend so much time dividing ourselves by borders, beliefs, and biology that we forget we're all members of the same improbable club, life on Earth. The moment we confirm that life exists elsewhere, our tribal squabbles will look absurdly small. Suddenly, we won't be us versus them. It'll be us and everything else that ever managed to wake up in the dark. And yet, there's another layer of meaning hidden in this search. What if we find life that's different? Not carbon-based, not DNA-driven, but something we've never seen before. That would be the biggest scientific revelation in history. It would mean biology can take entirely new paths. Maybe some worlds use silicon instead of carbon, or ammonia instead of water. Maybe evolution has crafted forms of intelligence that don't need eyes, or hands, or even bodies. The universe could be filled with minds that experience existence in ways we can't even imagine. That idea is both thrilling and humbling. It makes our species' accomplishments, art, science, music, exploration, feel both precious and small, like the first songs sung by children in a vast cathedral of stars. If we ever meet our cosmic cousins, they might not look like us, think like us, or even recognize us as alive. But maybe that's not the point. Maybe the connection isn't biological, it's philosophical. The fact that multiple worlds manage to produce consciousness at all means that the universe has a way of turning chaos into meaning. Life, in whatever form it takes, is the cosmos reflecting on itself. The more places it happens, the more complete that reflection becomes. And, perhaps, in a strange twist of irony, it will be our exploration of Mars that teaches us how to listen for others. By studying how life might have started, or ended there, we learn what signs to look for elsewhere. Every drill sample, every atmospheric reading, is a clue not just about Mars's past, but about the odds of life thriving anywhere. It's as if Mars is whispering, if it happened here once, it can happen again. For all its dust and silence, Mars might be the key to proving that the universe is alive. And that realization would reshape our purpose. No longer just explorers, we'd become participants in a cosmic story that stretches far beyond our world. We'd finally understand that intelligence isn't the goal of evolution. It's the method by which the universe learns to know itself. So, when we search for life beyond Earth, we're not just looking for microbes or megacities. We're looking for family. We're looking for affirmation that the spark that lit our oceans also touched other worlds, that were not a lonely accident, but part of a grand, ongoing experiment in consciousness. Finding our cosmic cousins wouldn't just change how we see the stars, it would change how we see ourselves. And in that moment, when we finally hear the faint echo of another world saying, "We were here too," we might realize that survival isn't just about staying alive. It's about remembering that we belong to something far greater than any single planet, a vast, living universe still learning how to speak through the dust, the silence, and the stars. In the end, maybe the idea of a Martian civilization isn't about them. It's about us. Mars is a mirror, showing us what happens when a planet loses balance. Whether we find ancient ruins or not, the message might be the same. Civilizations, like planets, don't get second chances. There's something poetic, almost unsettling, about the way Mars stares back at us through the night sky. It glows faintly red, a color that has always meant warning. Sailors once looked to red skies as omens. Soldiers painted shields with it, and now we look to a red planet as if it's trying to tell us something across the void. Mars doesn't shout its message. It whispers. And what it whispers is a truth as old as time. That existence, even on a planetary scale, is temporary. For all our telescopes and rovers, the real discovery on Mars might not be a fossil, but a feeling. Standing there, imagining it, at least, on that quiet, cold world, we see the ghost of what could be our future. The cracked ground, the empty valleys, the silence. It all looks eerily like the aftermath of something once vibrant. Maybe nothing ever lived there, or maybe everything did, and it ended not with a bang, but a slow red fade. Either way, Mars holds up a mirror and asks us to look closely at our reflection. Humanity has always been obsessed with mirrors, both literal and metaphorical. We built myths and machines to understand who we are, and now we've sent our reflection to another world. The rovers that crawl across Mars are our avatars, metallic extensions of human curiosity. When they send back images of the desolate plains, they're showing us more than geology. They're showing us the fragile line between life and silence. Mars, once possibly alive, now perfectly still, is a preview of what happens when a world forgets how to sustain itself. It's tempting to think of Mars as a cautionary tale for planets, but it's equally a cautionary tale for civilizations. We humans are very good at building, consuming, and expanding, but not always at balancing. Every empire that's ever fallen on Earth has left behind ruins, relics, and lessons we too often ignore. Mars is just the next level of that story, a civilization-scale parable written in rust. Even if we never find evidence of Martian cities or cultures, the metaphor still holds. A planet, like a civilization, depends on delicate equilibrium. Tip it too far, through neglect, greed, or natural decay, and recovery becomes impossible. That's what gives Mars its haunting power. It's not just the planet next door, it's the ghost in the cosmic family photo. It shows us what remains when progress outruns protection, when a planet's resources or resilience run dry. Maybe Mars wasn't destroyed by its inhabitants, but the result is the same. A once hospitable world transformed into an uninhabitable relic. That image should make us pause. Because every time we look at Mars, we're not just looking at another planet, we're looking at a possible version of Earth's obituary. But there's another side to that reflection, a more hopeful one. Mars also represents endurance. It may have lost its water, its atmosphere, and possibly its life, but it's still there, orbiting patiently, preserving its scars. It's not a failed planet. It's a survivor of cosmic time. And in that survival lies a quiet kind of wisdom. Mars reminds us that destruction isn't the end. It's transformation. If we learn from it, perhaps we can transform too, before our balance tips beyond repair. Every scientific image of Mars carries a dual meaning. The jagged cliffs of Valles Marineris, the endless dunes, the polar caps, all of it is both alien and familiar. It's like flipping through an old family album and realizing one of the faces looks uncannily like yours. Mars feels like home because, in some ways, it once was. It shares our building blocks, our chemistry, even fragments of its rock flung to Earth by meteor impacts millions of years ago. We are, quite literally, made of the same stuff. That connection makes Mars's desolation feel personal. Its silence isn't just the absence of sound, it's the echo of what could happen when the music stops. And yet, the human response to that silence isn't despair, it's determination. We keep sending missions, dreaming of colonization, of bringing Mars back to life. There's something profoundly human in that urge to revive what's lost, to heal what's broken. We look at a barren planet and think, we can fix this. Maybe it's arrogance, or maybe it's hope. Maybe both. But in that effort lies the essence of who we are. A species that sees ruins not as endings, but as invitations. Still, Mars warns us to be careful. If we ever do settle there, the red planet will test not just our technology, but our humility. It will remind us every day that balance isn't something you conquer. It's something you maintain. The first breath we take in a Martian dome, the first crop we grow in its soil, will be a triumph, but also a responsibility. Because the moment we forget the lesson that Mars represents, we risk turning not just that world, but our own, into another red reflection of neglect. So maybe the real significance of Mars isn't about what we find there, but what we bring back. Not samples of rock or data charts, but understanding. The understanding that progress without preservation leads to silence. That civilizations, no matter how advanced, are still bound by the same laws of nature that govern planets. That survival depends not on power, but on balance. When future astronauts stand on Mars and look back at Earth, a tiny blue shimmer in the sky, they'll be staring at a living world reflected in a dead one. They'll see two planets side by side, one thriving, one hauntingly still. And in that moment, the message will be impossible to ignore. Mars will be saying, without words, "Learn from me. Keep your sky blue. Don't become me." Because in the end, the story of Mars isn't really about Mars at all. It's the story of what happens when a world forgets its limits. It's the red reflection in the cosmic mirror, reminding us that while the universe gives us endless possibilities, it rarely gives second chances.